Hello, this is the section 6.2 lesson. In this section we're going to continue talking about division, and we're going to talk about the connection between division and fractions, and we're also going to talk about the closely related idea of remainders. So first let's just kind of review a couple of things from last section. When we talked about division, we had some different notations for division. We have something A divided by B. This is the most common notation we'll use. We can also use this fraction notation, or we could use this sloppy slash notation or this other notation. What we're going to do now is talk about this relationship between division and fractions, and we're going to stress the fact that the relationship there is more than notational. There's a much deeper relationship between division and fractions. Another thing to remember is that we have two different types of division problems. We have a how many groups type of problem and then a how many in each group type of problem. And we're going to use both these types of problems in this section, and we're going to figure out which type of problem we have by drawing those pictures that we talked about in last section. So in our first example, we're going to use this to illustrate that connection between division and fractions. So here's the simple problem. 2 pies are to be divided equally among 5 people. How much pie will each person get? And so here's a picture of this problem we can draw. We'll put our 2 pies at the top. We're going to give some pie to the first person, some pie to the second person, some pie to the 5th person. And so we see that we've got 5 groups here. We don't know how many pies are going to go to each group, so this is a how many in each group type of problem. Now we can solve this by taking 2, the total number of items, and divide it by the number of groups, which is 5, and that equals question mark. So that's our problem that we need to solve. Well, in order to solve this, or to try to solve it, let's convert this over to an equivalent multiplication problem. And so the problem is 5 is equal to question mark times 2. And so we say, well, what whole number would solve that equation? Well, there is no whole number solution. Okay? No whole number solution. So that leads us to the question, well, what number is 2 divided by 5? We just determined that it doesn't equal a whole number, but there are other types of numbers like decimals and fractions. So what number is this quotient 2 divided by 5? Well, to solve this problem, let's try to draw some pictures. And so let's draw our pictures of our 2 pies here. And let's divide each of these pies up into 5 pieces. So I'm going to draw 1, 2, 3, 4, 5 lines there, and then do the same thing over here. So we're going to pretend that all of these pieces are the exact same size. So why did I divide these up into 5 pieces? Well, because I've got 5 people. So now I think, well, how could I distribute these pieces of pie among the 5 people? Well, one way I could do it is let's take this piece and give it to the first person, and let's take this piece and give it to the first person also. And then this piece, let's give it to the second, this to the second, and then the third, and the third, and the fourth, and the fourth, and then the fifth, and the fifth. So the point here is that each person gets 2 pieces. Each person is going to get 2 pieces. So now let's think about what number this 2 pieces would represent. Well, we took our whole pie here and divided it up into 5 equal pieces. And so that looks like we're talking about fractions here. So we took our whole, divided it up into 5 pieces. Each person gets 2 of those pieces. And so those 2 pieces equals the fraction 2/5. And so there's our answer. What number is 2 divided by 5? 2 divided by 5 is equal to 2/5. So there's our answer. 2 divided by 5 equals 2/5. Now we're doing more than just changing notations. At first glance you may say, oh well, this is obvious. All we're doing is using one notation here and another notation over here. But we're making a far deeper connection between these two symbols than just notation. What we're saying here is that the quotient 2 divided by 5 is equal to, or is the same thing as, the fraction 2/5. So we're making this deep connection between division and fractions. What we're saying in general is that if I take a number a divided by b, that quotient is equal to the fraction a divided by b. So again, this is more than just notational relationship. We're saying that this quotient here equals this fraction right here. So there we go. Using this, we could solve any division problem in terms of fractions, but as we're going to see in these next few examples, that a fraction may not always be the best answer. So here's our next problem. Miss Karen has 9 candies and distributes them equally among her 4 students. How many candies does each student get? So here's our picture. We got our 9 candies at the top. We're going to get some of those candies to the first student, some to the second, some to the third, some to the fourth, but we don't know how many candies each student is going to get. So we see this is a how many in each group problem. So to solve this, let's take our number at the top, 9, and divide it by the number of groups, which is 4. And so now, using our ideas that we just talked about, we could write this as the fraction 9/4. So we think, well, okay, what exactly does this fraction 9/4 mean? Well, let's convert this over to an to a mixed number. So as a mixed number, this would be 2 1/4. So what does that answer 2 1/4 mean? So one way we could answer this problem again is that 9 divided by 4 is 9/4, which is 2 1/4. So as a mixed number there, this would mean that each student gets 2 1/4 candies. Now, depending on the situation, that answer may or may not make sense, specifically the fraction of a candy. If my candies are, say, big Snickers bars, 1/4 of a candy means I need to take one Snicker bar, divide it up into 4 equal pieces, and then each student would get one of those pieces. Now, it's very possible to cut up a big Snickers bar into 4 pieces and give those out. That's possible. But if I'm giving out like 4 little Jolly Ranchers, little candies, hard candies like that, I really can't cut those up into 4 equal pieces and give them out. So, depending on the situation, this answer may not make sense. So we need to think of a better way of answering this question. Well, to come up with a better answer, let's make an observation here. Here's our division problem, 9 divided by 4 equals question mark. As an equivalent multiplication problem, it looks like this. 9 equals 4 times what? So I think, well, what whole number would solve this multiplication problem? Well, there isn't a whole number that we take it times 4, we get 9. And so we think, well, could I come close to solving this problem? Well, 4 times 2 is 8, which is almost 9. To get equal to 9, I just need one more. So 9 equals 4 times 2 plus 1. So let's think about what this answer would mean. Well, the 2 here would mean that each student gets 2 whole candies, and then the plus 1 would mean that we have 1 candy left over. And that leftover candy we're going to call the remainder. So some notation here, 9 divided by 4 equals 2. That's the number we get right here, with a remainder of 1. So there's maybe a better solution to our problem, that each student is going to get 2 candies left over, each student is going to get 2 candies, and there's going to be 1 candy left over that maybe Miss Karen can eat, or maybe she'll save it for later, or do whatever. So this is probably a better answer, 2 remainder of 1, than the answer of 2 1/4. So this problem here illustrates our first use of a remainder. In this problem, the remainder gives the number of items that were left over after we distributed what we could equally. Now we're going to have a total of 3 different uses of remainders. Our second example is going to illustrate our second use. So here's our problem. You have 9 sticks of butter for baking cookies. If each batch of cookies takes 4 sticks of butter, that's an awful lot of butter. So how many batches can you bake? Well, let's draw a picture of this. We've got our 9 sticks of butter. 4 sticks are going to go into the first batch. 4 sticks are going to go in the second batch. And we don't know how many batches we're going to be able to make. So this is a how many groups type of problem. Now, this could be solved by taking our total number of items, divided by the number of items in each group, so 9 divided by 4. And so let's use our notation that we saw in the last problem, and write this answer as 2 remainder 1. So let's think about what that answer of 2 remainder 1 could mean in the context of this problem. So the 2 here means that I could make 2 batches, and then the remainder of 1 means that I have 1 stick left over. Okay? Now that answer could make sense, and that's basically the same interpretation that we used in the previous problem. The remainder gave me the number of items that were left over. In this case, a stick of butter left over. But let's look at another way that we could interpret this. So I could take that 1 additional stick of butter and use it to make a partial batch. Well, if a batch takes 4 sticks of butter and I only use 1 stick, I think what fraction of a batch could I make? Well, I could make a quarter of a batch. And so this is another way to interpret this problem. I could make 2 full batches plus a quarter of another batch. And that answer could make sense in the context of this problem. So this problem illustrates our second use of a remainder. It gives the fraction of a group that we could make with the leftover. Our last example is going to illustrate our third use of a remainder. A father has $9 to give equally to his 4 children. How much money does each child receive? Well, here's our picture. We've got our $9 here. We're going to give some of that to the first kid, some to the second, some to the third, some to the fourth, but we don't know how much each kid is going to get. And so we see this as a how many in each group type of problem. So we can solve this in the same way as we solved the other 2 problems. We're going to take 9 divided by 4, which in remainder notation is 2 remainder of 1. So let's think about what this answer can mean in the context of this problem. So one way to interpret this is that each kid gets $2 with $1 left over. Maybe the father keeps that for himself, or he saves that for later, whatever. That could make sense. And another way to interpret this is that each kid is going to get 2 whole dollars, and then we're going to take that extra dollar and distribute that evenly among the 4 kids. So that means that each kid is going to get a quarter of another dollar. Well, we typically don't use fractions to talk about dollars. We typically use decimals. And so a quarter of a dollar is 25 cents or 0.25. So this would mean that each kid is going to get $2.25. So this illustrates our third use of a remainder. The remainder gives the fraction or decimal that each group gets. In this case, a kid was a group, and so we use that remainder to determine what fraction or decimal of an item that each group gets. So we see that there's lots of different uses of remainders. It can give us more than just the number of items left over. And which of these 3 interpretations is the most appropriate depends on the scenario. In some scenarios, a number of leftovers may be just fine. In some cases, we want to convert that over to fraction. In other cases, convert over to decimal. It just depends on the scenario. So that's it for the section 6.2 lesson. Your assignment before next class period is to read section 6.2 from the textbook.